So a cup of tea with temperature 95 degrees centigrade. So the initial temperature of the cup is 95 degrees centigrade. Okay. Is placed in a room with a constant temperature of 21 degrees centigrade. What is the room temperature? 21 degrees centigrade. As your room, it is also in 21 degrees centigrade. Okay. Like this, in this room, how it was, the constant temperature is maintained. The same way, the teacup is also put up in that room, and its initial temperature is 95 degrees centigrade. How many minutes will it take to reach the temperature 51 degrees centigrade? Actually, initially the temperature is 95 degrees centigrade, and he is asking the time at how many minutes after the teacup, you know that slowly it was decreasing its heat. So after how many minutes, the temperature of the cup of tea will be 51 degrees centigrade. If it cools at 85 degree centigrade, because actually it was initially it is 95 degrees centigrade, he is giving one clue to us, that is it will be 85 degrees centigrade in 1 minute. Okay. So you can answer that, sir, in 1 minute it is decreasing 10 degrees of temperature. Automatically to getting 51 degrees centigrade, approximately it will take 6 minutes or 10 minutes. We can calculate directly, but it will not work. The heat of the cup of tea, it depends upon the room temperature, surrounding temperature. If some surrounding temperature is more than the tea, it should not be getting this kind of decrease of the temperature. Okay. So we will discuss some concepts on temperature, and then we will move to the present question. Exercise 8.6. So here we are using Newton's law of cooling technology. So Newton's law of cooling technology, it says capital T will be the temperature of the item of body. For example, here the body is teacup. Its temperature at any time, it is not constant, it is always changing. We already discussed about that. According to room temperature, it is what is that called? It is decreasing its temperature. So at particular time, the temperature will be capital T, and T dash. T dash is room temperature or surrounding temperature, you can call it. And it was fixed value. T dash is a fixed value. T is a temperature of the body. Okay, Hemant, your temperature also increasing or decreasing? Increasing, always changing. That is T. But room temperature is fixed. It is T dash is fixed. Okay. So rate of the change of the temperature of the object, that is what T. Rate means with respect to time it is changing. So we have to write dt by dt. Okay, dt by dt. I said 2 times T. Don't forget that both T's are same. One T represent body's temperature, and another T, small t, it regards on time. Okay. So time changing, according to that, the temperature is also changing. Okay. So that's why it will be proportional to what Newton's law of cooling says. It is the rate of change of the temperature is directly proportional to T minus T dash. That means difference of the temperature of the body. Body means here teacup, and room temperature. Room temperature is T dash. Difference means minus. Whether it was bigger or smaller, whatever it is, T minus T dash, just write down that. And after that, it is equal to minus K into T minus T dash. You have to use this equation to solve that question. Remember this equation. So the question is regarding on temperatures. You should use this technique. dt by d small t is equal to minus K into T minus T dash. Okay, why minus K? Minus K because the temperature is gradually decreasing its value. So that's why it should be always indicated with a negative sign. That means it is decreasing, it is indicating. Okay. So this is the concept. Now we will move to the question part. So write down the given parameters. The given parameters are as follows. So room temperature, copy it. So write down room temperature T dash is equal to how much? 21 degrees centigrade. 21 degrees centigrade. T is equal to temperature of the body, temperature of teacup. Don't write body also. Here it is a teacup, he said. Teacup at a time t. At time t. At any time. At any time. So we can create the equation. So write down dt by d small t is equal to, make some space. If possible, we will write some more precautions what he is mentioned in the question. Dt by dt is equal to minus k times of, what is that? T minus T dash, remember this. And T dash was 21 degrees centigrade, so you can write minus k times of T minus 21 degrees centigrade. Oh, whatever it is, k is greater than whatever it is, write down, okay? So we have to solve this equation. Here the unknown things are copied, this one. So dt by t minus 21 is equal to minus k into d small t. I just moved this part, dt part, to right side. Okay. Now write down next step, integrating on both sides. On both sides. Integrating on both sides. What you will get integrating on both sides? Integrating on both sides, we will get integral 1 by t minus 21 d capital T is equal to integral minus k into dt. Okay. So that means log mod t minus 21 good, is equal to minus k into small t plus c. Here, what are the unknown things? Unknown things are, we need to calculate further. C is how much and k is how much. These two values we need to calculate for further using the given hints. Okay. Fine. Understood? Is that? Okay. So how you are getting this C? Remember always for any equation in this application of, yes, Trijit. Oh yes, integral dt is t is Trijit. X. So always this integral dt, this d and this integral are inverse operation. They got cancelled. What left? T. That is the answer. So therefore, for getting initial conditions, we need to find out the first value C. So for that, what we are doing is we are moving to initial stage. Initial stage t is equal to t naught at starting point. We are starting the program when t is 0. From that we are counting. Okay. So t is always 0. And the capital T is how much at the initial stage? The cup of temperature of E is how much? 98 degrees centigrade. So we are substituting these values in this part to get this value of C. Okay. So log 98 minus 21 is equal to minus K into T. The T value is 0 here plus C. So K into 0, it will be 0. So we are having only, how much is this 98 minus 21? 77. Very good. 77. Since it is a positive value, there is no need of writing this model. 98 or 95? Tell me correctly. 95. 95 cup T initials. 74. Okay, 74. This is 0 plus C. Therefore, we are getting this constant value, C value, log 74. In integration, it is called a particular solution. Okay. In differential equation and integration, getting the C value by substituting some parameter like t equal to 0 and capital T equals some 95 or something. That is called particular solution. Therefore, now the differential equation becomes log mod T minus 90. Is it 95? Initial stage? No, room temperature, right? 21. Where 95, so just look at here. Where? Oh, sorry, 95 it is. 95 it is. Okay. And is equals to, oh, a little bit better. Better. Thanks. Minus k into small t plus log 74 it is. Okay, now you can move this part, logarithmic part in the left side. Log mod t minus 21 minus log 74 is equal to minus k into small t. We need to calculate this value. Actually, what we needed here, we needed the small t value. How many minutes of time it is taking to decrease its temperature? T is question mark here. Before that, we have to get a value of this k value. For getting this k value, just now we solved C value by substituting initial conditions. Remember this point. For getting C value, we have to move to initial conditions. Okay. And for getting k, he will give you some clue on the question. Okay, I will show you that clue also. So log of t minus 21 divided by, you can write 74 is equal to minus k into t, right? Okay. So now he given that, what is the given condition? He said in 1 minute something happened. What is that? Given that, what he said in 1 minute, what happens? Temperature is dropped to how much? 85 or 65, tell me. 85 degrees centigrade, right on. So now I am substituting these values. So small t will be 1 and capital T will be 85. Okay. So write down capital T will be 85 minus 21 divided by 74 is equal to minus k into t value 1. So we got k value. So therefore we are getting k value. So therefore k value is equal to minus, or keep this minus here, keep this minus k. Okay. So k value is equal, can you tell me 85 minus 21 is how much? 64? 64 out of 74. So this is the value of minus k. Therefore, the complete equation is, now tell me the complete equation. The complete equation is log T minus room temperature 21 divided by, what is constant value? 74. How much is it? 74. 74. Okay. Take modulus is equal to, what is the value of minus k? Minus k value is log not 0. 64 by 74. 64 by 74 into small t. Now this is a final equation. This is the final equation. You can use this final equation to get any value. Anytime you can calculate this part. So what is required? What is required now? What is the temperature he is asking in the question part? Check the question part. That was clue. He is asking, look at this. How many minutes will it take to reach temperature 51? We need small t value. He said 51 degrees centigrade. Capital, yes, right down here. Capital T is 51 degrees centigrade, small t is equal to question mark. Now we will calculate this small t value for this equation. Understood this question? So don't get confused. Very easiest question. So log of, all you need to only one formula. That is integral dt by t minus 21 is log mod t. The other hand, integral 1 dt is small t and constant c. That's it. So log mod, how much is capital T? 51 minus 21 by 74 is equal to log 64 by 74 into t. Now tell me how much is it? Log 30 minus log 74. Okay. Log 34 minus 74. Yes. What is So log of m by n. No? So that's why I wrote like log 64 minus log 74 is equal to small t. Is equal to small t. Okay. Now tell me log 30 is how much? You know that logarithm value, how to calculate. Open your textbook, go to the last pages, logarithmic values. For 30, characteristic is how much? Tell me fast. Characteristic value, you have to follow the logarithms also because no one is helping in your examinations. You have to use the logarithms. Learn it. Yeah. So it's a two-digit number. So 1.30 is how much? 4771. Okay. Minus. Now tell me how much is this log 74. Characteristic is 1 because it's a two-digit number. 8692. Okay. Do subtraction. Tell me it's log 64 is how much? 8062 minus log 74 it is 8692. We already wrote in the numerator. So is equal to t. This is the time particle. Okay. Now, so can we do subtraction? 11 minus 2 is 9. 16 minus 9 is how much? 7. 6 minus 6 is 0. We are getting negative value. 14 minus 8 is 6. Minus. Okay. Next. Do subtraction. 2 minus 2, 0. 6 minus 9, how much? 16 minus 9. Come on. 7. It is 9 minus 6 is 3. And this is 17. Yes, 9. So minus is equal to t. So minus minus you can cancel. You have to solve it. Yes. Tell me. So tell me the logarithm of the numerator. No, logarithm. It was the value. Actually, if you are doing multiplication division, then antilog is needed. For it is a general calculation, addition, subtraction, don't look at the antilogs. Okay. Come on, do the subtraction. Can you make it? Division, sorry. Tell me fast. 2 by 3 point. 2 by 3.2. 0.69. Okay. 0.6487. So, right now we have calculated the differences. How to in board? Board, yeah, board exam. Can you do this subtraction again? Maybe it is. No, subtraction. Do the subtraction. Maybe it is getting wrong. Do the subtraction. Tell me the values.
Minus 0.3921.
Okay. So 1.4771 minus 1.8692. It is minus 0.3936. How much? 3921. Okay. Again.
Minus 0.063.
Okay. Wait. I will check. 1.8062 minus 1.8692. How much? Minus, yes, we did wrong before. 0.063. Now do it. Now it will be T is equal to, okay, no problem, copy it. This is the correct values. This is getting 6.22 minutes. Write down 6.2. Okay, no problem. 6 minutes or 6.22 minutes, it is correct, accurate. Okay. No, it is too much long. The temperature not 51 degrees, then it will be 45 degrees or something. If you change 1 second, gradually it is decreasing. No, very important to tell. So 6.22 minutes. Shall we move to the next question?
How do we do this decimal division?
Okay, very good question. Okay, I will tell you. Okay, tell me this part. 3 take logarithm. Tell me logarithms. 1 bar means how much? 1.392 is how much? Check it. Make it fast. Everyone, make it fast. It is very important. In examination, it will take so much time if you are not working. 5933. Okay, look at the denominator. How much is the characteristic value? 2 bar. 2 bar it is. Okay, 2 bar. 6330 is how much? 6330. 630, sorry. 630. 7993. Now do subtraction because it's a division. 3 minus 3 0. 13 minus 9 is 4. 8 minus 9 is 9. Okay. This is 8. It was borrowed to 3. It is 8. 8. So 18. Okay. 18 minus 9 is 9. And this is 4. So 14. Okay. So again it is 2 bar then. It is 4. Sorry, 14. 14 7 is 7. So it will be 0 because we are doing subtraction. No, it becomes plus 2 minus 2 got cancelled. Fine, understood? Now tell me look at anti-logs. Come on, do it. Anti-log. Anti-log of this part is how much? 0.7940 or 7940. Yeah, this is the value. So it is a, look at this, characteristic value 0 means after 1 digit, you have to put that dot. Subtraction. Okay. Here I am writing. So actually it is 1 bar 5933. This is 2 bar 0.7993. Okay. Let's do subtraction part. 3 minus 3 0. So 3 9 we can't do that. Okay. Borrow 1 from this. Now it is 13. 13 minus 9 is 4. Now it is 8. This 9 is not 9, 8. So now 8 we can't subtract 9. So what we do? We can borrow from 5. So 18 minus 9 is 9. Now it is 4. 4 you can't subtract this 7. So now borrow one more thing, one more unit from the before digit. So it will be 2 bar. Minus, yes. You have to decrease, no? So it is already minus 1. And one more unit you are taking. So that means minus 2 bar. So this 14 7 is 7. And look at this. Here we are doing subtraction because it's a division. So minus 2 minus of minus plus 2 0. Understand? Yes. Next question. Next, 12th question. No, 11th question. A cake is removed from. So all of you know that cake. Question number 11. Try this question. So read this question. A cake is from an oven at 250 Fahrenheit and left to cool at room temperature 70 After 30 minutes, the temperature of the cake is 150 Fahrenheit. After how much will it be 100 Fahrenheit? That is the question. So again, write down the major values. What is initial temperature T0? 250 Fahrenheit. Oh, Fahrenheit. Okay. So some clues it was given after 30 minutes. After 30 minutes of time, the temperature become how much? After 30 minutes of time, the temperature will be 150 Fahrenheit. This is the only clue. Okay. And he's asking capital T is equal to 100 Fahrenheit. So getting this temperature, what is the time required? What is the time required? Understood this question part? Initially, the cake is 250 Fahrenheit, like a cup of tea was 95 or something. After 1 minute, the cup tea becomes some temperature it got. So in the same way, after 30 minutes of time, the cake got 150. So its temperature is decreasing. Okay. And now what is the question is, at getting 100 of Fahrenheit, what was the time? How much time required to get this temperature? Okay. Now we will move to the cooling part equation. What is cooling part equation? Newton's cooling equation is d capital T by d small t is equal to minus k of
T minus T dash.
T minus T dash. Yes. Oh, T minus T dash. Right. T minus T dash. Okay. T dash is how much? Room temperature. What is the room temperature in my mention?
250.
Cool room temperature. Look at this here. Room temperature, which is 70 Fahrenheit. So room temperature is T dash. It is 70 Fahrenheit. Okay, now use these values to get the answer. So write down d capital T by d small t is equal to how much? Minus k into k of T minus room temperature is 70 Fahrenheit. Okay, don't write that Fahrenheit. So d capital T by T minus 70 is equal to minus k into dt. Now integrating this part. Integrating on both sides. Integrating on both sides. Integrating on both sides. Integral d capital T by T minus 70 is equal to minus k into integral 1 dt. So it will be log mod T minus 70 is equal to minus k into small t plus c. Okay. For getting values, small t is 0 and t is equal to how much initial temperature? 250 Fahrenheit. 250 Fahrenheit. Now we will substitute these values. So log mod 250 minus 70 is equal to minus k into 0 plus c. So what is c value? Tell me how much? 180, am I right? 180 log 180. This is c value. After getting c value, write down again the equation. Log t minus 70 is equal to minus k into t plus log 180. This is very, very easiest questions. Log of t minus, definitely you will face one application of the dE. Yes, this is the highest weightage topics, calculus part. Integration, derivatives, maximum, minima, all these differential equations is most important. So minus kt is equal to minus kt. We need to calculate this value of k. So how do you identify this k? We already know that some of clues are given to you. So given t is equal to 30 minutes of time and temperature is equal to how much? 150 degrees Fahrenheit. Now we will substitute these values to get the k value. So log 150 minus 70 divided by 180 is equal to minus k into 30. Oh, am I right? Okay. So how much is this? 150 minus 70. How much? Do subtractions. 80 by 180 is equal to minus k into 30. Don't say this 30 go to cancel to 80. It is logarithm value. Don't cancel like that. So you can cancel 0, 0 here and 8 and 4 this part. In 4 by 9, yes. 4 by 9, 1 by 30. This is what? Minus k value. Okay. So k value also we have. So now the complete equation is so tell me complete equation, log mod of T minus, what is temperature, room temperature? 150, 250, room temperature.
That's it. What happened? Okay, oh, 70 degrees.
T minus 70 is equal to what is minus k? Minus k is 1 by 30 log of 4 by 9 into T, am I right? So this is complete equation. Now we are using this equation to get the time period. What is the required temperature? What is the required temperature now? Check the question. Required temperature.
100 degrees Fahrenheit.
So 100 degrees. Look at here, I just wrote here. Temperature 100 degrees centigrade at what time is required? Small t is equal to question mark. So log of 100 he wants, 100 minus 70 is equal to 1 by 30 times of log 4 by 9 into t. Now 30 is moving, okay? So 30 log 30 divided by log 4 by 9. Okay, this is what time t. So we need to calculate this part. Come on, tell me 30 of log 30 is how much? Come on, make it fast. Log 30, just now you said some 4771.
477.
Yes, 4771 divided by log 4 is how much? 2 log 2. Wait, 2 log 2 it is. 2 of log 2 minus log 3 is equal to t. Okay. So multiply with 30. Make it fast. 30 into.
That is log 4 by 9, which is half of 4 and 1.
1.4771. What I'm reading. 44 point how much? 313.
Log 4 by 9.
Yes, log 2 how much?
Log 2 is 20.
0.20.
0.3010.
0.3010. Minus log 3 is 0.4771. Okay, do its subtraction in the denominator. So 44.313 multiply with 2. Very tough question. 0.4771, 0.3010. Come on, do subtraction. 167, 1.0.
0.1761.
Multiply with 2. 2, 6 2s are 12. 14, 15, 1, 2, 2 and 3. 3, yes. 0 point is equal to t. What about?
About the log 4. About log 4/9. How did you calculate it? That is not what I want to do.
What am I?
About log 4/9, how did you get 2 log 2 minus log 3? Oh, sorry, 2. So that's it. So, log 4/9. Yeah. How did you reduce 2 of log 2 minus log 3?
It is 2 by 3 whole square. 2 by 3 whole square. Okay. Okay, now calculate this part. How much is it? Okay, remove this minus. Sometimes it is getting negative. Now calculate this value. Tell me the logarithmic value, everyone. So in 44, 44 is how much? 44, 2-digit number, 1.443. 6464. Now look at the next part. This is 0 means 1 bar. 1 bar point. On 35, 2 is how much?
5, we do it. 2 and
35, 2. Logarithms.
5455.
5455. Now do subtraction. 14 minus 5. 14 minus 5. 9. This is 0. And this is also 0. And this is 1. And subtraction, Lord. Not subtraction. 2. 2. 2. Now tell me this value.
Plus 1. So 2.1009. Okay.
Anti-log only you have to check 10, 0, 9. These two, don't look at these two in anti-logs.
0.10, 0, 0. Plus 3 actually. 12. Wait. 1262. Sir, 1262.
1262.
1 minute, sir.
Can I check with this part?
Sir, 1262. Yes. Otto.
44.313. 1.6464. And log of 0.3522. So log value is minus. It is minus 4532, right?
Hello.
You are telling 4532. It is wrong. This is wrong. Okay, I am using calculator to calculate this part, not telling correct answers. So this value will be how much? 66.3 minutes. 66.3 minutes. Okay, done? Copy this value. 2. Done, completed. Next question. 12th question. So a radioactive substance distinguishes at a rate of proportional to the amount substance present. At 50% of the given amount disintegrates 1600 years. What percentage of the substances disintegrate in 10 years? Some e power value was given. Okay. So write down solution. So here he said radioactive substance distinguishes. Radioactive substance, it's often taken as M. Distinguishes at rate means derivative part. dm by dt is called rate, proportional to. So this is the symbol of this proportional to. So according to this, you have to create a equation. Okay. So carefully observe this question. Radioactive substance means M. And rate means dm by dt. Proportional means proportionality to the amount substance present. What is the amount substance present at t? Time t, m. Okay, write down m is equal to, write down the steps. What is m? Substance present at time t. At a t time. At t time, what is present? Substance, that will be m. Okay. So you can write dm by dt. It is also always decreasing. So you can take minus km. Radioactive elements means is always diffusing. It is always diffusing. So that's why take like this. And do it integration. dm by m is equal to minus k into dt. Minus k into dt. Okay. Copy it. Now integrating. Integrating on both sides. Integral 1 by m into dm is equal to minus k into integral dt. It is 12th question. Now, what is this logarithmic integration? Log m is equal to minus k into t plus c. Okay?
So dm by dt alpha.
Proportional. Question says proportional, so that's why it will be. So at the initial time t is equal to 0, what is the substance value? Let us suppose say m naught. M naught is our initial value. We don't know this M naught value also. We need to calculate this initial mass is how much that substance will be. Okay, now we will substitute these values here. So log M naught is equal to minus K into T. T as 0 here. So therefore, finally, integral constant is nothing but log of substance, logarithm of the substance of the mass of the radioactive element at initial stage. Now the equation becomes log m is equal to minus kt plus log m naught. Okay, now we will move to this logarithmic part, logarithms on the same side, making logarithms on the same side. Log m minus log m naught is equal to minus kt. That means you can write log m by m naught is equal to minus kt. We need to calculate this k value. Okay, we need to fix it out. So what we do? Okay, make it fast. The question says, look at the question. The question says It's very important. Look at this question. The question says the substance is 50% after 1600 of years. After 1600 of years, for example, if you took 1 kilo of the radioactive element, then after 1600 years, it will be how much? Its mass will be half kilo, because you took initially 1 kilo of radioactive substance. So after 1600 of years, it will be how much? Half of that part. Half of that part. Okay. So therefore, m naught is equal to m is equal to. Now m is equal to how much? M naught by 2, half of the part of the initial mass, and t is equal to how much at that time? 1600 years gone. After 1600 of years of time, the mass will be half of that part. So write down m value will be m naught by 2 by m naught is equal to minus k into 1600 of years. Okay, done. Next, m naught got cancelled. So log 1 by 2 is equal to minus k into 1600. Now E is equal to. So write down this log 1 by 2 means log 1 minus log base E is always. In logarithms, we are using log base 10. In calculus, we are using often log base E. Remember this. So minus k into 1600. So log 1 is 0. You know that log 1 is 0. So minus log 2 is equal to minus k into 1600. So minus minus got cancelled, both sides. Okay. Now k is equal to how much? 1 by 1600. 1 by 1600 into log 2. 1 by 1600 into log 2. Now we will write the original equation. Now therefore the equation is what is the equation now? Log m by m naught. The equation is log m by m naught is equal to minus k into t. Okay, what is minus k value? Minus k value log 2 by 1600 into t. This is the actually equation, final equation. Okay, from this final equation, we will check one more time the question. According to that, we will decide the time period. So check the what percentage of the substance in 10 years, he said. 10 years. After 10 years, what is that substance will be? He is asking that. So after 10 years, so write down. So let X% of substance disintegrates in 10 years. X% of left, okay, after 10 years. X% left means m value will be how much? M value will be m naught into X% left. X% left means 1 by X by 100 after of 10 years. Okay, m value will be this part. Now we will substitute this value. We need to calculate the value of x. Now log m means m naught into 1 minus x by 100 divided by m naught is equal to minus log 2 by 1600 into 10 years, no? So write down 10. T value 10. T value 10. Make it first equation. So from first equation, right? We are substituting this m value after 10 years. How much left? We assumed that x part of the substance left. So we are using this calculation. Now you can cancel 1 0 from here. And m naught got cancelled. Log of 1 minus x by 100 is equal to minus log 2 by 160. Okay, this is base E. Now what to do? You can calculate the x value. So 1 minus x by 100 is equal to e power minus log 2 by 160. And look at this, we have this value. So he was given that e power minus log 2 by 160 is 0.9957. Look at this part. Yes, write down that. 0.9957. 0.9957. Log always is having base E. Okay, can you subtract it? Minus x by 100 is equal to 0.9957 minus 1. How much is this? Minus 0.00. How much? How much? Tell me. 43. Am I right? So minus minus got cancelled. X is equal to how much? How much percentage left? 0.43. 0.43 percentage left. So this is the answer. 0.43 percentage left substance. Okay, understood, everyone? Shall we move to the next question, 13? We have 16th question, 18 questions. Copy 13th question. So read this question. The rate at which radioactive substance known to be proportional to mass of the substance present at the time in the given sample. If 100 grams of radioactive substance is present in 1 year after substance was produced and 75 grams is present 2 years after the substance was produced, how much radioactive substance was produced? Okay, write down solution. So make the equation, make it equation dm by dt is dashly proportional to how much? M. So you can write dm by dt equal to minus k into m. Minus k into m. Okay, dm by m is equal to minus k into dt. Now integrating on both sides. Integrating on both sides. The same model we have to do it here also. Integrating means, you know, integral dm by m is equal to minus k into integral dt. Okay. So this will be log m is equal to minus k into t plus c. Log m minus k into t plus c. Okay. 14. 13. So at initial stage, t value will be 0, m value will be m naught. At initial stage, the substance. Okay, now we will substitute here. Log m naught is equal to minus k into 0 plus c. Therefore, c is equal to log m naught. So after getting this c value, we have to substitute the c value in the equation. Okay. Therefore, log m is equal to minus kt plus log m naught. Now you have to move this log m naught to left side. So log m minus log m naught is equal to minus k into t. Okay. So how can you write this? Log of m by m naught is equal to how much? Minus kt. Now we need one more condition to get rid of this k. So what is the condition? Let me check the condition. The condition says in 1 year, the m value will be 100 grams. Take a look at the question. Take a look at the question. 100 grams. If 100 grams of the radioactive substance present in 1 year. Okay, underline this question. Underline this part. 100 grams radioactive substance present in 1 year. Okay. In 1 year, that much of radioactive substance is present. Okay. So we are going to substitute t value 1. Write down given that t value 1 and m value will be how much? 100 grams left. 100 grams left. So now this is log 100 by m naught is minus k into t value 1. Therefore, minus k value will be log of 100 by m naught. So this is the value of k. We don't know the initial mass of the substance is how much. Okay. Copy it. So now substituting, therefore the final equation is log m by m naught is equal to minus k value how much? Log 100 by m naught into t. This is minus k value, okay, into t. What he said next? He said after 2 years, we will check one more time the question. He said after 2 years of time, 75 grams left after 2 years. What he said? 100 grams left in 1 year. Okay, we calculated that k value. Next, what he said, 75 grams left in 2 years. Okay, 75 grams left in 2 years. So write down here in this equation, m value will be 75 grams, t value will be 2 years. 2 years. Now we are substituting these values here. So log m value 75 divided by m naught is equal to log 100 divided by m naught, and t value is 2 years. We need to calculate this m naught now, okay? So what we do? Okay, multiply with 2 and use the log m minus log n, log of m by n formula. Use log of m by n formula. Log m minus log n. Okay. Completed? Can anyone suggest, is there any another way to solve this question? 75 by m naught. You can write this multiple as whole square. Can I write that? And log you can cancel. So 75 by m naught is equal to 100 square means 100 into 100 by m naught square. M naught square, m naught got cancelled. Mr. 75, 100 got cancelled 3 times, 4 times. Okay. So 3 is equal to 400 by m naught, which implies that m naught is equal to 400 by 3. Yes, tell me, can you divide this? Yes.
How did 2 become square?
Huh? So n log x means log x power n. It's a multiple, no? So you can write inputs whole square. Log, you can cancel log on both sides. Square means 100 into 100, m naught square. M naught. After log was vanished, right? So you can do the. So what is this m naught value? Tell me. 400 by 3 is how much? 133.33. So this is the answer of this question. Is it done? Understood? Can I move to the next question? Okay. Completed? Next question. 14. Yes, copy it. Radium decomposes at the rate of proportional to the amount present. Okay, write down dm by dt. He said proportional to the present. Present means mass. Okay. So you can write, this implies it is decomposing, he said. Decomposes means minus kt. So dm by dt is equal to minus k into m. Now integrate it. Dm by m is equal to minus k into dt. Now integrating on both sides. Integrating on both sides. Okay. Integrating on both sides. Integral dm by m is equal to minus k into integral 1 dt. Yes, how much is this? Log m is equal to minus kt plus c. You know how to calculate the c value. Now we will substitute m value, t value 0 and m value m naught. Initial substance. Okay. Now this will be log m naught is equal to minus k into 0 plus c. Therefore, c is equal to log m naught. After getting this c value, we will substitute the c value in the equation. Okay. Every question will be, process will be same. So just you can practice 2 or 3 times. Will understand. Will understand these problems. So log m is equal to minus kt plus log m naught. So you can move this logarithm to the left side. So you can write directly log of m by m naught is equal to minus kt. We need to get this value of k. Now take a look at the question part. So radium decomposes at the rate proportional to the amount present. If half of the original amount disappears in 1600 years. Half of the part gone. Okay. So find the percentage lost of 100 years. So now what is M now? M is half of the part gone. M is equal to half of the part gone. How much time it is taking? 1600 of years of time it was taking for getting loss of the for the decay of the decrease in this mass. So log of M value will be M naught by 2 by M naught is equal to minus K into 1600 years of time. So M naught got cancelled. Log 1 by 2 is equal to minus K into 1600. So you can write log 1 minus log 2 is equal to minus K into 1600. Okay, log 1 is how much? You know that log 1 is 0. Okay, log 1 0. Log 1 0 minus log 2 is equal to minus K into 1600. So minus minus got cancelled. K is equal to 1 by 1600 into log 2. So therefore the final equation is what is final equation? Log M by M naught is equal to K value is 1 by 1600 into log 2 into T. This is the final equation what we got. And check again the question again. Check the question again. What he said? He said in the question that find the percentage lost in 100 years. So X percentage, we can assume that X percentage loss we having in 100 years of time. Let X be the percentage loss of 100 years. Let X be the loss in 100 years of time. Now M is equal to how much? M naught into 1 minus X by 100. Okay. We will then log of M naught into 1 minus X by 100 divided by M naught is equal to 1 by 1600 into log 2 into T. T value is how much? T value will be 100 years. 100 years of time where we have loss of that mass. That mass. Now the mass is X. Okay. This is 100. T value is 100. Okay, understood. Now 1600. Yes, M naught got cancelled. Yes. 1600 this got cancelled. So what left? Log of 1 minus X by 100 is equal to log 2 divided by 16. Okay. What is log 2 by 16 value? So 1 minus X by 100. X by 100 is equal to e power log 2 by 16. We just know that value, right? Log 2 e power log 2 by 16. Come on, tell me how much is that? 0.6931. Okay. Now minus X by 100 is equal to 0.6931 minus 1. How much is this? Minus 0. Come on, tell me. 9603. Okay, therefore X is equal minus minus got cancelled. So 30.69 left. 30.69 left. Is that correct? Yes, tell me, or can I apply logarithms? You are not calculating correctly, just wait. You are getting wrong answers.
What is this?
Calculate this value. Log 2 by 16, how much? Come on, calculate that. Oh, yes. This value. Where it was given? In the question.
0.0188.
Okay, no problem. What is the, tell me log 2 value? 0.3010 upon 16. Okay.
Why 16 is 0.1?
1 minus x by 100 is equal to e power 0.3010 upon 16. This value will be e power e power 0.30103. How much is that? 0.301. First calculate 0.30103 divided by 16. It will be 0.0188. Now e power 0.0188. Okay. Now calculate e power 0.0188 is how much? Make it fast. Can I do that? E power 0.0188. It will be 1.0189. This is 1 minus x by 100. Okay. So I will show you here. E value, where is E? E value. E value power, how much? 0.0188. Look at this value. This value I copied. 1.0189. So minus x by 100 is equal to, subtract it, 0.189 minus 1. How much? Minus 1. 0.0189. So x is equal to, do cross multiplication.
1.89.
into 100. Into 100 means what? 1.89. So 1.89% approximately. 1.89% approximately the diffusion will be happening. Hmm. Hmm. Okay, done. Next question. Question number 15. Hmm. Approximately.
I think they're getting the chance of 1.8.
He's asking the percentages. Calculate the percentage values. Then in the overall substances, we have to calculate the percentage value. Yes, copy it. Next question. You have to move that. Finish this question.
Breaks. Break time.
What break time?
3:30, sir.
3:30, sir.
Only 2 questions. Okay, break. Take break.